Okay. Hi guys, it's me, Miss Cribs. And I don't want to feel like holding the camera, so you're kind of far away, but I hope you can still see me in my junky office. But I just want to take some time and talk about absolute value equations and absolute value inequalities. That is what this video is going to be about. So, without further ado, let's go ahead and jump into absolute value equations.
Okay, absolute value equations. So let's talk about the definition of absolute value. So absolute value means the distance from zero. So on the paper, I have a number line, and then I put zero in the middle. So if you think about the absolute value of 5, so if I put absolute value of 5, this is going to be equal to 5. And the reason that it's equal to 5 is because if I put the number 5 on the number line, this number 5 is 5 units away from 0. The distance from 0 is 5 units. And likewise, if I put the absolute value of negative 5, it's also going to be equal to 5. So if I put negative 5 on the number line, look how many units it's away from 0. 5 units. So the distance from 0. The reason why I'm saying this is because, as you notice, if you take an absolute value, you're going to end up having two different answers. So if I have the absolute value of x is equal to k, that implies that x could be equal to k, or x could be equal to negative k. I have two different answers here. Okay, your first example here. When you're dealing with absolute value equations, the first thing that you want to do is make sure that your absolute value is on one side by itself. You want to make sure that the absolute value is isolated. So on this example, the absolute value is on one side by itself. So there's no need to worry about the first step here. It's already isolated. The next step is to split this equation into two, because you're going to have one that's equal to 5 and then one that's equal to negative 5 according to the rule of absolute value. So on this one I have x minus 4 over 2 is equal to positive 5. And then I have x minus 4 over 2 is equal to negative 5. So I have my two equations. Step number 3 is to solve each equation. So for the first equation, I'm going to multiply everything by the LCD, which is 2, to get rid of the fractions. And that gives me x minus 4 is equal to 10. Add 4. And so I get x is equal to 14. And then I go on the other side and do the exact same thing to the other side. I need to solve for x. So I multiply everything by the LCD, which is 2. And then I add 4 to both sides. And I end up getting x is equal to negative 6. And this is my second answer. Okay, on this example, our absolute value is not isolated. So, step 1, I need to get the absolute value isolated. So what I'm going to do is subtract 1 from both sides. And when I do that, I get absolute value of 6 minus 2x is equal to 2. Now my absolute value is isolated. Step 2 is to split it into two equations, one where it's equal to 2, and then the next one where it's equal to negative 2. Step 3, I solve each one of my equations. For the first equation, I get x is equal to positive 2. And then for the second equation, it's minus 6 on both sides. And then I divide by negative 2. And I get x is equal to positive 4. These are my two solutions. And one more example I want to point out let's say if I have the absolute value of 8 minus 3x is equal to -4. Now, absolute value means the distance from 0. So I have the absolute value of something is equal to -4. So I'm saying that the distance from 0 is equal to -4. That can't happen. You can't have a distance equal to a negative number. So for this particular example, it's going to be no solution. Let's say if you have a absolute value equal to an absolute value. So to solve this one, it's almost similar to the previous one we did, but it's one extra step that we have to do. So if I have an absolute value equal to another absolute value, the way that I break this up is I say that A is equal to B, and also A is equal to -B. So that probably looks familiar from the previous examples we did, but our A and B can be polynomials. So let's look at an example. Let's say if I have absolute value of 4 minus 3x is equal to the absolute value of 2 minus 3x. So I have the absolute value of one polynomial is equal to the absolute value of another polynomial. So the first equation that I write, I'm going to write it and just ignore the absolute value symbols. So nothing changed. The second time that I write it, I need to have -b. So negative times the whole polynomial. So what I did here was I put -1 parentheses 2 minus 3x. So I know to distribute that negative sign to everything in that polynomial. So now I need to solve each one of these. I add 3x to both sides, and then something weird just happened. Both of my variables canceled out, and I end up getting 4 is equal to 2. Now 4 can never be equal to 2. So I don't have a solution for that left-hand side, which is okay. Now on the other side, I'm going to distribute the -1. I'm going to move my variable terms together. So I'm going to subtract 3x from both sides. And that gives me 4 minus 6x is equal to -2. Move the 4. So I get -6x is equal to -6. So dividing by -6, I get an answer x equals 1. So my only answer here is x is equal to 1. Okay, absolute value inequalities. So I chose to break this up into two different cases, case number 1 and case number 2. So let's focus in on case number 1. Case number 1, I call this an in-between type problem. And I call it an in-between type problem because of the way it looks on a number line. So if you have an inequality that says less than or less than or equal to, then I call it an in-between type problem. So if you have something that looks like absolute value of x is less than k, or even absolute value of x is less than or equal to k, because it says less than or equal to, I call it in-between type problem. So before I even start, I know what the pictures look like. So let me draw the pictures for each one of these. If it's a less than symbol, it's an in-between problem. That means I have two numbers on my number line. In this case, I'll have open circles at each number, and then I shade everything in between the two numbers, hence the name. Likewise, with less than or equal to, I have two numbers on my number line, but in this case, it's closed dot at each one of the numbers, and I still shade in between the two numbers. That's why we call this case in between. So I need to go through and figure out what the math is going to be in order to figure out what the values are on the number line. So I take the value that's inside the absolute value and I put it in between a negative k and a positive k. Likewise with the less than or equal to, I take the value that's in the absolute value, which is x, and then I put it in between negative k and positive k. But on this side, I have less than or equal to for my inequalities. So this is the generic form. Let's take a look at an example to see how this works. Let's say if I have the absolute value of 3x minus 4 is less than 2. That means that this is going to be an in-between type problem. So if I draw this on a number line, I have two numbers, an open circle at each one of the numbers, and I shade everything in between. This is the picture. Now let's do the math to figure out what the two values are going to be. The thing that's in the absolute value, 3x minus 4, I'm going to put it in between negative 2 and positive 2. And then I have my strict inequalities. So the goal is to solve this. In order to solve this inequality, I have to get x in the middle by itself. So I'm going to start out by adding 4. If I add 4 in the middle, it'll make the negative 4 disappear. So I have to add 4 to both sides. That gives me 2, and then 3x and 6. Now I have to divide by 3. That means dividing by 3 on both sides. So I get 2 over 3, x, and a 2. So I have solved this inequality. The two values that I found, 2 over 3 and 2, I put them on the number line in order. 2 over 3 and 2. And this is my solution. I want to be able to put this solution in interval notation, so I put parentheses, 2 over 3 and 2, close parentheses. This is my solution. Let's take a look at another example. So this absolute value inequality, we are going to start out by isolating our absolute value. So in order to isolate the absolute value, I need to add 2 to both sides. And I get absolute value of 5x plus 1/2 is less than 7. Now, according to this inequality, this is an in-between type problem because it says less than. Less than means that my picture is going to be an in-between type of graph. So I'm going to go ahead and draw my number line. I'm going to draw the two numbers. I put an open circle at each one of the numbers and I shade everything in between. The goal now is to figure out what those two numbers are going to be. So I'm going to take the value that's in my absolute value and put it in between negative 7 and 7. So the 5x plus 1/2 goes in the middle, and then I put negative 7 and 7. Now, in order to solve this, I'm going to multiply everything by the LCD just to get rid of that fraction. The LCD in this case is going to be 2. So what I'm going to do is multiply everything by 2. That means all 3 sections. So the first, I multiply by 2. The middle part, I multiply by 2. The right hand side, I multiply by 2. So I get negative 14. In the middle, I get 10x plus 1. And then on the right hand side, I get 14. Now the goal is to get x in the middle by itself. So let's do the work we need to do to get x in the middle by itself. I subtract the 1. And then I'm going to divide by 10 in all 3 sections. So negative 3 over 2 X is in the middle, and then I have 13 over 10. I have the X in the middle by itself, so this is completely solved. So I put these numbers on my number line, negative 3 over 2 and 13 over 10, and this is my solution. I want to put this in interval notation, so parentheses, negative 3 over 2 and 13 over 10 parentheses. Case number 2. Case number 2 is called opposite directions. So opposite direction means that you're going to have an inequality that's going to be greater than or equal to. So on the paper I have absolute value of x is greater than k. And then I have absolute value of x is greater than or equal to k. Both of these are opposite direction type problems. That means that when I graph them on a number line, I'm not shading in between two numbers, I'm going in opposite directions. So for this first one, I got open circles at each one of my numbers, but instead of shading in between, I'm going to shade in opposite directions. Okay? Likewise with greater than or equal to. I have my number line, I have the two numbers. In this case, we're going to have closed circles or closed dots. And then I shade everything in opposite directions. So you see how this is a little bit different than the in-between type problem because of the way the picture looks. Now, because you have two different intervals, you're going to have two different inequalities to solve. So the first time you write your inequality, you just drop the absolute value symbols. The next time that you write it, you want to flip the inequality and you want to make the number negative. So again, on the right hand side, you want to write it the way it looks without the absolute value, and then the second time you write it, you want to flip the inequality and change the sign of the number. Again, this is all the generic form, so let's see this with numbers so you can understand what I mean. So let's say if I have the example absolute value of 3x minus 4. Is greater than 2. Greater than or equal to 2. So according to this inequality, this is an opposite direction type of problem because it says greater than or equal to. So before I even start to do the math, I know what the picture looks like. So I draw a number line, I put two numbers down, I have closed dots at each one of the numbers, and I shade opposite direction. This is before I even start to do the problem. Now because I have two intervals here, I'm going to have two inequalities. So the first time I write it, I'm just going to write it the way it looks, just dropping the absolute value symbols. Then the next time that I write it, I have the inequality flipped and I put negative 2. So notice the two inequalities that I have here. The next step is to solve each one of the inequalities. So I add 4, I divide by 3, and I get x is greater than 2. So let me solve the other inequality. I add 4, divide by 3, and I get x is less than or equal to 2 over 3. So this tells me the two values that I have on my number line. I put the 2 over 3 first and I put the 2 second because I want to put them in order. Last, I want to put my shaded area in interval notation. This is negative infinity to 2 over 3 bracket union with bracket 2 to infinity. Okay, one more example with the opposite direction type of problem. So on this inequality, I look at the absolute value, it's already isolated, and then I look at the inequality. The inequality says greater than, so that tells me this is going to be our opposite directions. So I draw my picture. I have my number line. I have two numbers. It's going to be an open circle at each one of the numbers, and I shade in opposite directions because this says greater than. Now I have to do the math to figure out what are the two numbers that go on the number line. So I write the inequality the way it looks without the absolute value symbols. And then the second time that I write this inequality, I flip the inequality and I put negative in front of the 2/9. So now I need to solve each one of these individually. So I'm going to multiply by the LCD to get rid of the fractions. The LCD in this case is going to be 18. So I multiply everything by 18. If you do 5/3 times 18 in your calculator, you're going to get 30. Okay. If you do 1/2 times 18, you get 9. If you do 2/9 times 18, you get 4. So now all of my fractions are gone and I can solve for x. So I subtract the 30 and I get negative 9x is greater than negative 26. Now I need to divide by negative 9. Because I'm dividing by a negative, I need to flip my inequality. Whenever you divide by a negative, you need to flip the inequality. So if I reduce 26/9, I can't reduce 26/9. Never mind. So let's scratch that idea. Let's leave it 26/9. Now let's solve the other inequality. Multiply by the LCD, which is 18. 5/3 times 18 is going to be 30. 1/2 times 18 is 9. And negative 2/9 times 18 is going to be negative 4. So I subtract the 30 now, and I get negative 9x is less than negative 34. I'm dividing by a negative 9, and because I divided by a negative, I got to flip my inequality, and you end up getting positive 34/9. So these are my two values that go on the number line, and the 26/9 goes first because it's smaller, and then the 34/9 goes second because it's larger. And I put both of these intervals in interval notation. So this is negative infinity up to 26/9, parentheses, union with parentheses, let's do 34/9, to infinity, close parentheses.